Welcome back to Statistical Reasoning. We are now moving on to Chapter 2, Summarizing and Graphing Data. We're going to work with the first section, Frequency Distributions for Organizing and Summarizing Data. We'll talk about how to make a frequency distribution, the different parts that you can include in it, and we'll actually make one so you can go through the process together. So here is an example of a frequency distribution shown to you. This first group, which is labeled pulses per minute, is actually the classes. They are the different groupings that you are breaking your data down into. The frequency is the next column. It is how many times each subject occurred. So there were two subjects that had pulses per minute from 60 to 64. 7 subjects had pulses per minute from 65 to 69, and so on. Now, frequency distribution totally could just be these two columns right here and be done. Or maybe they don't have the frequency and they have the cumulative frequency. Or they could just have the relative. That's the nice thing about a frequency distribution. You can choose some options. If you look at the cumulative frequency, the 2 stays the same for the first group. The 9 is the first group plus the second group. So it's the cumulative. It's both of those together. The 20 is the 2 plus 7 plus 11. The 35 is all 4. And so it's accumulating this as we're going along and putting the total down, which means the last group is going to be how many total subjects were in the study that you were looking at. The last column is where we've changed all the data into percentages. That means that's the relative part of this. The first one here, the 3.17%, is the percentage of subjects that were in the 60 to 64 group. Now this is a cumulative relative, and we will do both a cumulative and just a relative frequency. This 14.29% represents the percentage of subjects that are from 60 all the way to 69%. So it's both of these groups together as a percentage. So let's go ahead and look at some of the definitions, and then we'll get started on making one ourselves. So some of the things that we need to know. First, the first group of numbers that we see as we go down the first column is the lower class limits. They are the smaller numbers that you can see in each of the classes. So for instance, the 60, the 65, 70, 75, 80, 85, and so on, those are the lower class limits. The upper class limits, the larger numbers that belong to the different classes, so those are the 64, 69, 74, 79, and so on. And then we have class boundaries. Class boundaries are the gaps between, and what happens is we split those apart, split them between the two different classes, and they represent the boundaries or the fences between the different classes. So if we look at this, we have 64 to 65. That's a difference of 1. We want to split that in half, so we get a half. And so we can represent our boundaries. So 64 plus a half would be 64 and a half. So that's one boundary. 69 plus the half is 69 and a half. 74 and a half. And so on, going this way. Now there is a boundary above this because I have a lower limit of 60. So the boundary actually previous to that is 59 and a half. And the largest boundary is 99.5. Now all of our pulses per minute are going to be whole numbers because you can't have a partial pulse per minute. You can't stop counting partway through a pulse. So these are partials, but that doesn't mean that our answers are partials. They're just boundary lines. Two more definitions before we start making one. We have our class midpoints. And if you think about what a midpoint is in any other definition, it's the same thing here. It's the number in the middle. It just happens to be in the middle of our class numbers here. If you want, depending on the difficulty of the numbers, you can add the lower limit plus the upper limit and divide by 2 to find the class midpoints. In this situation, it's a little bit easier. We probably can do it without adding them. 60 to 64, they're 4 apart. Cut that in half, that's 2. So the middle of 60 to 64 is 62. And now if you add 60 and 64, you would get 124. Divide that by 2, you still get 62. 65 to 69, the middle is 67. 70 to 74, the middle is 72. 77, and so on down the line. So those are going to be the class midpoints. The last thing we need to note is what's called the class width. It is the difference between the two consecutive lower class limits, and that's important. Notice it's not between the lower and the upper, it's between the two consecutive lower class limits. So as we go back and look at our example that we've been looking at, we're going to have a 60 to 65, so that's a difference of 5. 65 to 70, 5. 70 to 75, 5. So 5 is our class width. It must be the same the whole way down. We can't change it up and have one class width of 3, another one of 10, another one of 13, another one of 1. We must keep that consistent. Okay, so here we have some rules and some procedures to follow as we continue to make one ourselves. So the first thing we have to do is decide how many classes we would like to use. The rule of thumb is between 5 and 20. After that, we'll determine the class width. And while we're doing that, we're going to take the maximum data value, we'll subtract the minimum data value, and then we're dividing by the number of classes that we want to use. So if we chose 5, we would divide by 5. If we chose 15, we would divide by 15, and so on. We won't always get a whole number. Sometimes we will, sometimes we won't. We do want to make it nice to work with though, so usually if you end up with a number that's not convenient to manipulate, you can move it one way or the other. Usually it is rounded up to work with. The next thing we want to do is choose the value that we want to start with. We might want to make it lower than what we actually have within our data set, and I'm going to recommend doing that with our data set we're going to work with. Then we're going to start by making our first lower class limit and using our class width to start breaking them apart in steps 4 and 5. We'll then do it with our upper limits and then start making our tally marks. So the data set we're going to work with is McDonald's lunch service times. So we have some numbers here, 107, 139, 197. These numbers are representing how long it took for their patrons to get their meal at McDonald's. Notice it is in seconds, so this is 107 seconds. So it didn't even take 2 minutes for this patron to get their meal at McDonald's. So we're going to set this up. Here is already made frequency table. If you have printed these off, you'll have this and you can write in along with me. So the first thing we're going to do is we're going to go ahead and determine our class width. So in the directions from above, it said we need to take first we need to figure out, the number of classes. And I've already said let's try and do 5 classes. So the next thing we're going to do is our class width. I want to do the maximum number minus the minimum number and divide by 5 because I've determined to do 5. So when I was looking throughout the data, and you can do this too, I found an upper number of 308. That was the highest value I saw. The lowest value I saw was 83. And my goal is 5 classes. 308 minus 83 is 225 divided by 5. 225 divided by 5 is 45. So my goal is to have a class width of 45. And that is the distance or the difference between as I'm moving between my lower class limits. Now I don't necessarily want to start at 83. Not that it's a horrible number to work with, but it's not the most convenient. So instead of starting at 83, I'm going to start at 80. So I'm going to start in my chart. 80 will be my lowest number, my lowest lower limit. Now I'm going to add 45. 80 plus 45 is 125. I'm going to add 45 again, so I get 170. I'm going to continue to add 45 until I get down here to 60, 305. Now my upper number is 308. It's definitely going to fit within this last grouping here, so I'm going to stop. If you're not sure if it fits or not, you can keep going. I could have went to 350. And I'll leave it there for now, but I'm going to notice I don't need that last group. Now I need to come in and I need to put in my upper limits. So to find my next upper limit, I just look here. This is 125. I just want to back up 1. So 1 before 125 is 124. And then I just keep doing this. This was 170, sorry, that's a bad 7. Back up one, that's 169. Back up one, that's 214, 259, 304, 349. So here I'm verifying 308 is my upper number. Here it's the highest number I have. 349 is this upper limit. I do not need the 350, so I'm going to go ahead and erase that on out of there. So these are my classes that I have. So notice I did end up with 6 classes. Part of that is because I didn't start at 83, I started at 80. Sometimes it also occurs just because of the number that we ended up with our class with. It's okay, even though my goal was 5, 6 is not going to hurt anything. So now I'm going to go through and I'm going to mark in my numbers. So I simply go through the list. So if I look at the list, and again, hopefully you have this printed. So 107 is my first number. So I go over here and I look, where does 107 fit in? It's between 80 and 124. So I just put a tally mark. Sorry about that, it didn't mark. Let's mark it now. My next number was 143, which would be in this group. My next one is 100, which would be in this first group. 139, 130, 117, 197. So I'm just going through the list. I'm finding where those are in my classes, and I'm making a tally mark for each class. Now you can do that on your own. I don't want to take your time though in the video to do that. So I have gone ahead and made this ahead of time. So I end up with 11 in that group. The next one I have 23. Let's make sure, see if I can fit that in there. That's 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20. 1, 2, and 23. The next one ended up with 11. The next one ended up with 3, 1, and 1. Now I'm going to go ahead and I just put these together so I have an actual number versus just tally marks. That's 11, 23, 11, 3, 1, and 1. Now if I look back at the data set that was given to me, I really need to know how many numbers are in here. So I do need to count them up. So I have 3 per group, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 3 is 48, 49, 50. So I have 50 numbers. I have to make sure I have 50 numbers if I add up my frequency. If I don't, then I missed one or I counted one twice. So I need to make sure I do that before I continue. So 11 plus 23 is 34, 34 plus 11 is 45, 45 plus 3 is 48, 49, and 50. So I just take a moment and I verify that I do have 50 numbers, and I do. And I'm just going to put a 50 there so I know. Now the frequency distribution that I'm making right now is a working frequency distribution. If I were to present this information to somebody else, I would not use the tally mark column to do that. I would take that totally out. It should be typed up nice and neat. Okay, so I know how many people had to wait. So 11 people had to wait from 80 to 124 minutes. 23 people had to wait from 125 to 169 minutes, and so on. Even somebody had to wait for between 305 and 349 minutes. But you know, it's really only 5 minutes, so it's not that bad. So the next thing we're going to work on here is the relative frequency distribution. And I talked about this when I was showing you the original example. Each class frequency is replaced with a percentage or a proportion. So we're going to take the frequency for the class, divide it by the sum of all the frequencies, and then multiply it by 100 to turn it into a percentage. So here I have the data typed up nice and neat. So we're going to go ahead and do that. Now remember, we have 50 numbers all together. So we're going to do the relative frequency. So the math would be 11 divided by 50 times 100%. If I do that math, I end up with 22%. Then I'm going to do 23 divided by 50 times 100%. I do that math, I get 46%. And I just continue on. It's 22%, 6%, 2%, and 2%. Now when you're done making your percentages, just like over here in the frequency, when we were done, we needed to add them up to make sure there were 50 numbers. When you're making your relative frequency, you want to take the time to add up your percentages, make sure they add up to 100%. Okay? So now what I can see is that almost half of the time, patrons of McDonald's had to wait between 125 and 169 minutes. So they're waiting a little bit over 2 minutes, but not quite 3 minutes. And then as a company, you would decide if that's good or not. You should have what your goals are for your company. The next thing we're going to talk about is a cumulative frequency distribution. And again, we talked about this in the first example. We just want to see what's going on as we continue on down the chart. So here I have it again. We have our percentages written in now. Now we're going to do a cumulative frequency. So we're going to act like the relative frequency is not even there. So the cumulative frequency, we're going to do 11 for the first group because there's nothing else to be accumulated. Now the next number is going to be the 11 in the first group plus the 23 in the second group. So 11 plus 23 gives us 34. So that's telling us that 34 patrons had to wait from 80 seconds all the way down to 169 seconds. It's the first two groups together. Now we're going to take 34 plus 11, and that's 45. 45 plus 3, 48. 48 plus 1, 49. 49 plus 1. The bottom number on your cumulative frequency should be the same as however many numbers your frequency column added up to. Now, I don't have a slide that talks about this. I just want to go ahead and show you what it would look like, the cumulative frequency distribution. Same idea as the cumulative frequency, but we work with the percentages instead. So now we're going to do 22%. Next percentage would be the 22 plus the 46, so that's 68%. So that's telling me that really almost 70% of the patrons are getting their food in less than 169 seconds. Now I'm going to do 68 plus 22, so I'm at 80. 80 plus 6 is 86. 86 plus, how about let's try something. I totally messed something up, didn't I? Oh yeah, right there. Okay, let's fix that. Now remember, I am human, so I am going to mess up once in a while. It doesn't hurt you to see that. So 68 plus 22, let's try that's 90. Kind of threw out 10%. 90 plus 6 is 96. 96 plus 2 is 98. 98 plus 2 should be 100%. Okay, so I do have all of my data included. So I know all of my patrons in this study that I was doing got their meal in before 349 seconds were up. Now, one of the things that we use a frequency table or frequency distribution to do is see if it is what's called a normal distribution. We're trying to see if it's symmetric. So I'm going to show you real quick, and we'll talk about this more later on in the class. But this, you may notice, this is similar. Most people call it a bell curve. In statistics, we call it a normal distribution. The idea here is that most of the data is here in the center. So we're going to have a few, in this case, in the McDonald's instance, we're going to have a few patrons who are going to get their meals extra quick. We're going to have a few patrons who get their meals extra slow. But for the most part, our patrons are going to get their meals here in the middle. And that's what our goals are. We're shooting for our patrons to get their meals from here to here. We can use a frequency distribution to see if this is occurring. So if I look back here, and I'm going to look at the frequency chart, here's where most of our data is. Most of our patrons are getting their meals here. Notice that's not in the center. That's actually more toward the front, so we're going quicker. And then we still have a few of these. So this graph, in the way that we did it, does not look like a normal distribution. It's actually what's called skewed, which we'll get to, okay? If it was normal, instead, we would want it to look like they're in this group. This would be normal if most of our data numbers were here versus moved up where the blue is. Now, we also could look for gaps, and gaps are where there are actual zeros. Now, we didn't have any zeros in our data, so we didn't have any gaps. If we do have gaps, we would try and figure out what is causing those and what is the reason for them. So here we have an example of data which was it's pennies and what their weight is. So they weighed pennies in grams, and here are the frequencies. So we had 18 pennies that weighed between 2.4 and 2.49 grams, 19 that weighed between 2.5 and 2.59. Notice there's a gap. There were no pennies between 2.6 and 2.89 grams. And then we have some more information. So this one again is not normal. The data is not in the center of the frequency distribution. So we're thinking, okay, what is occurring? And it depends on how well you know your history. What happened was that they changed what they made pennies out of. So prior to 1983, they had more copper in their pennies, and now they've moved to having more zinc in their pennies. So the pennies actually have gotten lighter over time. As pennies are used and circulated and then taken out of circulation, even this will change. So our heavier pennies will no longer be around. That's these pennies down here. Those will get out of circulation and will end up not having this gap. But until then, this is what it looks like. So not only can you do what are the gaps are and what kind of things can that tell me, you can also compare more than one group. So our last slide that we're going to look at is comparing McDonald's and Dunkin' Donuts. So here are the percentages, and these are close to what we came up with, but not perfectly. So here are some percentages. This is McDonald's. Then they did the same thing with Dunkin' Donuts. Now at first glance, I see the Dunkin' Donuts numbers are up in the lower seconds, the upper part of the frequency chart. So Dunkin' Donuts is getting their patrons their food quicker, and McDonald's is taking longer. I've never ate at a Dunkin' Donuts. I don't know what they feed you, so I don't know if it's really comparing apples to apples, or if Dunkin' Donuts is giving you just donuts. Well, you can get a donut quicker than you can maybe make a meal at McDonald's. So you may have to make sure when you're comparing two people, even though you have to ask yourself, should you be comparing these two companies? So thank you for coming back. This is the first section of chapter 2, and we'll be back later with the second section.